All right, I'm going to go through this checkpoint and the solutions for you. So first thing we want to do is put our name on here, right? So you always put your name on there. So I'm going to put my name on here. We're going to go Caveman Bruce. All right, there we go. Make sure that a teacher knows whose paper this is. Okay. Now on number one, we're going to factor out a common term. You should always do this. Sometimes I forget. It's easy to forget sometimes, but every term has a 2x. So factor 2x out. I'm left with 3x squared plus 7x plus 2. Okay, that leaves me with a quadratic, so I'm going to try to unfoil that quadratic. And in this case, this one is a happy little problem. It unfoils 3x and whoopsie daisy. Getting ahead of myself. 3x and x, and then I'll put the 2 with the 3, so I want it there and the 1 there, and they're both plus. So this one says find all solutions, rational, irrational, or imaginary, and list multiplicities, so that's what I need to do. So what makes 2x 0 is 0 itself. 3x plus 1, what makes that factor 0 is negative 1/3. And what makes x plus 2 0 is a factor of negative 2. Okay, there we go. Number one, check. Number two, the notation's kind of funny here, by the way. It says 6x, and then the cubed isn't very, it should be up in the air, but it's not. So, I don't know, cut and paste. But number two, we have a cubic 4-term polynomial. So I'm just looking to see, this one might group. So I'm going to try to group this. And I believe it does group. So we factor out from the first grouping a 4x squared. And what's left is x minus 2. And from the next grouping, if I factor out a negative 1, I'm left with also x minus 2. So lo and behold, that does group. So we can factor out, it's like a binomial within a binomial. So I factor out that x minus 2 factor. And so what I have, after I factor out that binomial term, is x minus 2 times 4x squared minus 1. And looky, we have the difference of squares showing up. So we have x minus 2 times 2x plus 1 times 2x minus 1. Okay, list my roots. I have 2, which makes that 0, negative 1/2, and positive 1/2. 3 solutions for a 3rd degree cubic, so makes sense. All right, continuing on down here, I have another cubic polynomial with 4 terms, and just by looking at this one, I can tell it's not going to group. So now I need to do synthetic division, and I'm going to use the rational root theorem to determine what possible rational roots. So plus or minus p over plus or minus q. In this case, q is just 1, p is 2. So this is going to be plus or minus 1 or 2 over 1. So there's really only 4 things to try. So let's just go ahead and guess and check this stuff. My coefficients are 1, 6, 9, and 2. And I'm going to just go for 1, see if that works. So 1 times 1 is 1. 6 plus 1 is 7. 7, this ain't going to work. I can tell already. So go back, try a negative 1. Pull the 1 down, negative 1 times 1 is negative 1. Add those, I get 5. 5 times negative 1 is negative 5. Add those, I get 4. Negative 1 times 4 is negative 4. That's a negative 2. Darn, that doesn't work either. Go back again. There's going to be one question on the test where you have to do this. So you want to be pretty good with your synthetic division. Try a positive 2. 1 times 2 is 2. 6 times 2 plus 2 is 8. 2 times 8 is 16. Crust. This ain't going to work. All right. Well, it must be negative 2 then. So put a negative 2 in there. Pull down the 1. Negative 2 times 1 is negative 2. Add those, you get 4. Add those, you get negative 8. Add those, you get 1. Add those, you get negative 2. And lo and behold, I finally found my guess and check answer. My root is negative 2. So if negative 2 is a root, that means that x plus 2 was the factor. So now I've started factoring this. I have x plus 2 factored out, and what I have left is x squared plus 4x plus 1. So x squared plus 4x plus 1 right there is down to a linear and a quadratic, and so I take this quadratic stuff and I try to unfoil it. But that ain't going to unfoil, so I'm going to have to use my trusty old quadratic formula, plus or minus, so the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Okay, again, my a is going to be 1, my b is 4, and my c is 1. So put those puppies in, solve away. Opposite of b, that's negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 1. 4 times a times c, all over 2 times a, which is 2 times 1. Clean that up a little bit. And we have negative 4 plus or minus. I like to just get a different color and figure out what is this stuff inside the radical there. So that's going to be 16 minus 4, which is 12. Okay, so negative 4 plus or minus the square root of 12 all over 2. Okay, you can break that up and simplify. That's going to be negative 4 over 2 plus or minus root 12 is the same as root 4 root 3, but root 4 is 2, so that's the same as 2 root 3 over 2. So this one simplifies to be a little bit more happier than that. That's going to be like negative 2 plus or minus root 3. So we have two irrational roots. They're actual roots. They're not imaginary. They're irrational. So combined with the 2 that I started with, or wait, did I go all? Nope, that's good. So the 2 that I started with way up there, negative 2, that's going to be one of my roots, and negative 2 plus or minus root 3 is the other root. So negative 2 is a root, and the other 2 are irrational, they come in pairs, negative 2 plus or minus the square root of 3. Right, some of you might be kind of going, oh, well, I don't know what, I don't know. That's negative 2 plus the square root of 3 is one of the roots. Negative 2 minus the square root of 3 is another root. And just negative 2 is a root. So there's 1, 2, 3. Okay, the last one is the difference of cubes. So that is going to follow the identity for that, which is a cubed minus b cubed is always equal to a minus b times a squared plus ab plus b squared. Okay, so my a in this case is a cube root of x, so my a is going to be x, and my b is going to be cube root of 27, which is 3. So everywhere I see an a, I put an x, everywhere I see a b, I put a 3. So this factors like x minus 3 times x squared plus 3x plus 9. Okay, if I'm solving, I have one of my solutions now is 3. And then my other one is, well, this stuff never factors the leftover stuff from the sum or difference of cubes, so I have to go ahead and use quadratic formula again on that. Really? Quadratic formula again? Oh my gosh. Yep. Quadratic formula again. You should be proficient at using, and you should absolutely know the quadratic formula by now. So opposite of b, that's going to be the opposite of 3, so negative 3 plus or minus 3 squared minus 4 times 1 times 9 all over 2a, which is all over 2 times 1. Okay, clean that up. Negative 3 plus or minus the square root of, what is that stuff inside the radical? That's going to be 9 minus 36. 9 minus 36, that's like negative 27, I think. Okay, so negative 3 plus or minus the square root of negative 27 all over 2. All right, well, it looks like this is becoming an imaginary because I have the square root of a negative. So this would be like negative 3 halves plus or minus. There's going to be a 9 in there, so that's going to be the square root of negative 9. If I break this up and simplify, it's going to be square root of negative 9 times the square root of 3. The square root of negative 9 is 3i. So this will be 3i root 3 all over 2. So kind of a crusty answer there. It's an imaginary. So complex, imaginary solution. So this one will have two solutions. It will be positive 3. I think I just said two solutions. 3 solutions, positive 3, and then negative 3 plus or minus 3i root 3 all over 2. So there you go, unless I made some mistakes, and if I did, just let me know about it. And other than that, there's your solutions for the checkpoint that we did today. Ciao. Ka-chow.